teaching and get down to what it takes to deliver high quality instruction, which is a pretty tall order. It's 50 minutes, but we'll do our best. So we're going to start with leveraging the shifts, and you have on your table a handout. The second page looks like this page here. If you don't have one, I can get you one.
There's only one on this chair.
Oh, look, now you're going to have one.
Thank you. Maybe we can share.
Well, this one is, yeah, just turn to the second page. Okay. So what I kind of want to know about this, just to review the shifts, you do that yourself and answer for yourself which of them is least obvious or the biggest struggle to implement. Like, are you least clear on how to meet that shift? And we'll look at them actually as this original 6 that they used to be presented as opposed to these more concise 3. And just maybe mark on the page and then talk with your neighbor a bit about why you chose what you chose.
Sure, if you, once you teach every single day.
All right, let's wrap up the conversation and come back to the group.
Yeah.
Good. So, full disclosure, I prepared my presentation not knowing how you all were going to answer that question. So the bulk of my presentation is actually going to be focused on coherent thinking across grades and conceptual understanding, but I do have slides and I'm prepared to discuss the others as well. So I'm going to start, as I said, in those 2 areas, and I want to talk about, yeah,
Did you say why you were focusing in those 2 areas?
I guess I feel, just personal bias, I felt like there's some subtlety or challenge in thinking across grade levels coherently that's worth talking about. Okay. Yeah. And that it just ties nicely in with building conceptual understanding. So that's why, but I'm happy to talk about any of them. And I think we'll have time. The last time we did this session, we had time to talk about all. So I'm going to talk about 3 particular high-yield models that I think support this cross-grade coherence and conceptual understanding. Before I do that, I wonder if you could just jot a few notes of what you think makes a model, so something that you're sort of using in classroom either tutorially or as an manipulative, what makes it high yield? Like, why would you choose one model over another? I mean, investing in getting kids used to a model is an investment, and we have to think deliberately and carefully about why we do that. Your name is Eric?
Eric.
He was pointing out that sort of like with teachers grabbing from all different curricula to try to meet the standards or all different resources, it can feel really chunked and broken up and not coherent. And so I wonder if you might think about what would make a model sort of high yield or worth selecting and worth using. So I'll just give you 20 seconds to capture your thoughts there. What I think makes something high yield, I think the first criteria is that it would fuel understanding across multiple grade levels. Really fuel it, consistently be leveraged toward understanding, and that it would be across multiple grade levels. When you're using the same model year after year after year in more and more complex mathematics, that innately builds coherence. I think also it helps if it transitions well from concrete to pictorial. And if it relates nice to a traditional approach to solving the problem, or the traditional algorithm, or shortcuts, or things like that, if you can see those connections nicely. And I'm not going to feature the area model, but that's one such example, although I do have a slide later that shows the area model. All right, so there are 3 that I want to focus on. I'm going to start by just asking this question: how would you personally approach this problem? Just take a second to figure out what you would do to solve that. That would be your first step, next step. Share with your neighbor if you'd like. So David here was just describing what I observed when I went to see a 7th grade class that was implementing our curriculum, and there was an opening exercise. It was supposed to be kind of like a warm-up, and it was all doing this, and it brought the class to a screeching halt because their approach was, let's start by converting this to a mixed number, and when we get 11 fourths, now I got to get a common denominator with the 80, that's going to give me 320 fourths, then I do the subtraction, I end up with 309 fourths, and then what do I do with that? That doesn't help me much, and so then I got to reconvert that back into a mixed number to relate to the number. And some people converted to decimals. It was a hot mess. And so, but literally they were doing exactly what we've been teaching them to do, exactly what the model is teaching them to do. Because most curricula they use the number bond. So I'm going to feature this number bond in grade K1, very common to see that, and then it's dropped from there on out. And so what I want to talk to you about a little bit is the opportunity to continue to use the number bond in grade 2, for example, we suggest kids to constantly think about making 10 and taking from 10, right? So grade K in the Common Core has a standard of, I don't know that it uses the word fluently about decomposition, but essentially getting fluent in decomposing numbers up to 10, like all the ways you can decompose 8, all the ways you can decompose 9, all the way up to 10. And so that fluency is what supports them starting to support this addition, subtraction, understanding, and fluency, and not just trying to memorize facts incoherently. And so they'll use the number bond here to make 10, breaking 9 into 7 and 2 so that the 7 can join with the 13 to make a new 10. And they'll use the number bond again to take from 10, using it flexibly here. And for those parents or others who might be upset about, we should be teaching the standard algorithm, it's important to recognize that even in the standard algorithm, you still have to subtract 9 from 13, right? And if you're not viewing it and being flexible in your decomposition and thinking of 13 as a 10 and 3 ones, or in that way, then you're not really prepared. Taking the 9 away from just this 13 things is much less obvious than if you have that firm understanding as the 10 and the ways to decompose those. So here's another example. Again, I was working with the 5th grader the other day and posed with this problem. She went right to the algorithm, 301 minus 11, did the carry, then the count, all of that, when instead we want them to have that fluent decomposition of numbers. For me, I might have approached it as 290 and 11, or 290 and 10 and 1, and the 11 broken up. So here's an example of our use of the number bond in grades 3 and 4. That's a really healthy practice. Breaking up start usually by breaking up into 5-unit fractions, so 1/5, 1/5, 1/5, 1/5, 1/5. I say that 5 times, I think. And then experimenting with what are all the other ways I could break up a whole into fifths. Also in grade 4, thinking of it in terms of sort of a distributive property, and 9/10 can be broken up into 5/10s and 4/10s. And even in grade 5, really getting that understanding of the decimal being made up of this combination of a 10 and 300ths. So having this model be consistently used is what builds that sense of coherence across the curricula and empowers them to do this computation in a way that is actually efficient. And so the second one I want to talk about, we can walk through this. So if you didn't approach it that way to begin with, we can think about splitting up the 80 maybe into 78 and 2, 2 and 3/4 into the 2 and the 3/4 part. And then in the next step of the problem, so we can go ahead and subtract that 2 off. Then we can break up my 78 into 77 and 1, or 77 and 4/4, making that problem much more accessible. All right, the second model I want to think about, this is an example of a curriculum using that number bond with students in grade 3. So I actually want to pause here for a second and think about what other high yield models do you think you would consider, are you using today, or thinking about in terms of those criteria that we put forth. Anyone have some thoughts? Yeah.
Number line.
The number line. So the number line is definitely coherent, and it's really important. I also think it's a little bit harder in terms of like that transition from concrete to pictorial. It's pretty abstract in and of itself, but it's critical for all, and you will see that in all curricula. I shudder to think that there was a curriculum that didn't have a number line. Great. Yes.
We use quick draws a lot.
Yeah. So like.
Boxes for
Boxes.
for hundreds.
Okay, so that's interesting. It's a good lead-in. So I'm going to talk a little bit about place value. And I definitely support at some level, like at the K1, doing those groups of 10, like a straight line through the dots and sort of having that shortening notation. But in the place value, as we get into 4th and 5th grade, they're asking the students to really recognize and generalize the place value system, right? And I've definitely seen curricula, for example, that the guidance to the teacher is to say, discuss that a digit in one place represents 10 times what it represents in place, right? Like their guidance is just tell the teacher, discuss it with the kids. The kids' text says, hey, notice that a digit in one place represents 10 times, right? That's sort of the approach, because there's this ambiguity about how to really instill that understanding. And then generalizing that even further, that the digit 2 that's right is representing 1/10 of what it represents. And so when we think about place value models, it's really common, healthy for all kids to start here with bundling those popsicle sticks or straws or crayons. We use crayons in my house. And this is very frequently seen in curricula. I would challenge that it's really hard to extend this model into tenths. It's really hard to use it when you have numbers above 200, for example. Like when you got this stack of hundreds, it becomes really clumsy pretty quickly. And so just the same way that we don't carry around money that's 100 times bigger when it's a $100 bill, this non-proportional model for place value is actually really a high yield model in my opinion, and very seldom seen in curricula though. For kids physically constantly changing out 10 of these for one of those, they actually do that physical manipulative. And then, of course all always starts there. This is an example of how they sort of do this for a little bit and then quickly move into just the digits here in these place values. And so in contrast to that, you can move from actual concrete manipulatives into pictorial representation of those, and even into a more efficient, having just the dots and the label above saying what they're representing. And this will really take them all the way through 5th grade. These place value discs starting already in 2nd grade when they first start place value. And so here's just a couple of other examples of them being, problems being done using those place value discs pictorially. Questions about that one or anything? The third one, which I think is actually has made its way into curricula more and more since the Common Core, is the tape diagram. But I still think so many kids enter into 9th grade still having not, because the Common Core is relatively new, or even in 6th and 7th grade, I don't know how many teachers are fluent in using it themselves, and so the kids are still coming into algebra and having not really experienced a problem even as complex as this. I'll let you read it and think about. And technically, this is actually like a system of 2 equations and 2 unknowns, right? It's readily accessible to students using a tape diagram. So you could just, Amy has 5 times as many cards as Jack. Who has more, Amy or Jack?
And
Amy. So if Jack has this much, what would Amy's pile look like? 5 times that. What else could we, label on our diagram or observe from our diagram in relation to the problem?
36.
The total is 36, and then we can visually see that those 6 units. Most kids when they're approached with this problem here, it's one of my first assessment problems actually. Kind of depends where I think the kid is, but if I'm assessing a middle schooler or even a high schooler, I'll throw this out, and I actually wouldn't start here. If they struggle, I'll pull out some Starburst. Starburst are lovely I should actually be an advertisement. Lovely concrete math manipulative, because it just blends so nicely with looking at these tape diagrams. All right, so I also like them in their use of fractions. So I wonder, anyone here already familiar with using them to do a problem like this? Okay, I wonder if we might even, what is a word problem that would require this operation? This is a big gap in our knowledge as adults, math students from the US, I believe. Coming up with a word problem for that. I'll give you some time. Yeah?
You need 2 1/4 cups of water,
Uh-huh.
and your measurement is only 3/4 of a cup high. How many do you need?
How many scoops
How
will
many
it take?
scoops do you
Nice,
take?
Yeah.
I love that. So you have to go, the easiest access is to go with the measurement model. And that's lovely, and most of us struggle, when we think of division, we think of the sharing model, or they call it partitive. And having those 2 forms of division, it's actually like physically what you're doing with the thing. So imagine just the simple problem, 12 divided by 3. If I think of it as most people do, which is 12 divided by 3, I've got 3 friends, and I've got 12 cookies, and how many cookies can each friend get? They essentially grab groups of they grab one at a time and come like this, right? And they keep doing that until they run out. So that's one way to divide evenly. Or you could say, I want to give groups of 3, how many kids could I feed? And you're grabbing groups of 3 until you finish using them all up, right? There's 2 totally different approaches or models for division, and typically in our country we're only fluent in the one, and it makes it a lot harder to think of this, because you can't give cookies to half of a friend, but you can give each friend half a cookie, right? Okay, so the tape diagram, generally I recommend starting with defining what 1 is, and then maybe you could think about, well, what does 2 1/4 look like? So it might look like this, and what does 3/4 look like with respect to that? And so how many 3/4 fit into the 2 1/4? And it's actually helpful to get a common denominator when multiplying and dividing with fractions, even though we don't think so, or we don't teach it that way commonly. But having the common unit of fourths makes us be able to see quite easily that we can fit 3 of those 3/4 into the 2 1/4. So I consider tape diagrams to be another really high yield model, and I do think they're making their way into curricula pretty consistently now. All right, so in the standards, fluently, they use the actual word fluently in a small subset of like 7 standards only. And they suggest that it's sort of, it's just about automaticity of the calculation and the procedure for doing the calculation. But thank God, they had one little extra line in here that says that students should practice core functions so they have access to more complex concepts and procedures. So thank God they opened the door there, that it's not just about the conjugations, right? To be fluent in a language, or be fluent quantitatively, requires that you recognize real world situations, you can generate them yourself, yes, you can calculate quickly and accurately, but you also can absorb all of what you're doing and become fluent in it, so that you can move on to the next more complex thing. So I would suggest it's certainly not limited to those fluency standards. And so, I forgot to add a bullet here, I really wish I had, about, well, it kind of is encompassed in this one. We got this lovely debate in the last discussion about to time or not to time. And one of the big aspects of it, I think, is a big teacher judgment about the risk. It has to be low risk. It has to be low risk. Timing can be fantastic. It builds adrenaline, and adrenaline actually builds memory, and it's fun and engaging sometimes to be in a race, But they have to be conceptually prepared for that race. There's no reason to race if you don't have a really solid understanding of what's happening already. Like you started that cycle that Matthew was talking about several times, and you're building that, and now you're really just trying to get more efficient. So the timing of when you decide to time, and the being no risk involved for the student is critical if you're going to time assessments. We actually do have a lot of time. We use something called sprints. In our curricula, they're very deliberately sequenced, deliberately moves from simple to complex. I think that's important for building fluency. Immediacy of feedback, which again, Matthew talked about earlier in his talk, and the focus on like personal best or the improvement opportunity. And I think it should be regular, and you should think about it from multiple perspectives. Hold on a second. Well, these are just some examples. This is something people don't often think about as fluency, although I think it also ties nicely to some of what Matthew was saying. You do get some adrenaline also from like trying to solve this puzzle. So imagine how many ways and which ways, or is there a way that I could use each of the digits only one time to fill this in accurately? So you're going to do 1,000 addition problems as you're trying to figure out, is there even one that works? Is there more than one that works? Is there a high ceiling? Like, are you sure that's the only one that works? Is there another one that works? Lots of opportunity for growth there, and even the struggling kid is not feeling, they're practicing their addition to see if it works. So all of those are lovely. Oh, I really like this one too. Like, what are all the different ways to make 87 cents out of coins? Just because, again, constantly there's that higher level problem solving and trying to figure out, did I really think of all the ways and engaging differently? So, anyway, but I was talking about, what I wanted to get to was this slide about planning with purpose, that it's not just about, so you start midway through the year sort of building on the fluency of the skills that you're learning that year and maintaining them, getting better and better at them, but there's also You can also do it to remediate prior understandings from previous grade levels, or to prepare the kid from the lesson that they're going to have, sort of get them practicing again on something coming up. Okay, how are we doing on time?
Okay.
As in, we got 10 more minutes?
We have 10 more minutes.
Yeah. Okay. Other questions? If not, I think I'll go to particular, this slide here. Do I need to teach all the methods? So I was actually talking to Jason Zimba the other day. He's one of the original authors before, and he was talking about having been in a classroom where he was observing students using a strategy, and the teacher sort of like encouraging, yay, great, it's great, we use this great strategy, but him wanting her to nudge those students towards the next most helpful strategy, so that the strategies aren't just this random collection of tools. Yes, they are a lot of tools that you can use flexibly, but there's also sort of a natural progression to some of them. So for example, a student in kindergarten who might be working just on basic counting, and the first level is just that you're going to count all of the pennies and come up with 9. And you're wanting to nudge the student, essentially, as they begin to recognize this, this as 2 or this as 4, we could also just think about this as 4 and counting on. So it's not just about being happy, they got the right answer, 9, check, that's great. It's really watching their development through those strategies evolve closer and closer towards sort of an optimum strategy that will become either the standard algorithm or some most efficient strategies. So the next thing you would do with those pennies is you start to learn to skip count, counting by 2s, 3s, or something helpful of that nature. I'm sorry that these pennies were supposed to go away, but anyway, when you get a whole pile of pennies, I make piles of 10, which is a lovely next, still sort of a form of skip counting. And so here's, I continue the progression of strategies. We talked about this one here earlier, decomposing to make 10. And then this is actually the one that Jason Zimba had seen. So they had 3 times 50, which yes, you can do, count by 50s, 50, 100, and 150. But his goal that the teacher be aware to nudge those kids towards using that associative property to see this as 3 times 5 tens is 15 tens is 150, really increasing their flexibility around that. And this is where I have this area model here and connecting that to this very efficient notation. This is basically just a shorthand essentially for what we do when we first understand how to decompose and distribute to multiply bigger numbers together. Right? Do you want me, is this clear, or should I talk about this? So that was some lovely insight to really encourage teachers not just to be pleased with getting the right answer and saying, they can use any method they want. There's a reason that you're teaching the methods, and it shouldn't, not all methods should be weighted equally necessarily. You really should be aware of what is the progression, what are you going to, and nudging the kids along that direction so that you're seeing their evolution. Okay. Well, this is just a slide I threw in about transitioning from concrete into pictorial models and into abstract representations, about just how subtle you can get here between using something concrete and moving into a more abstract concrete model. And even pictorially, maybe at the teacher level only, you could use something like this, and then by the time the student is doing it themselves, it can be more abstract. And then we move into these other abstract ones that I was talking about. But always, I think it's important in the early years of, maybe in the 60s and 70s, after we realized that we were really messing up math education, that it really was important to learn math in this country. It was really after, I'd say, Russia launched Sputnik, and we were all sudden in this space race, so to speak. Prior to that, there had been a losing battle between mathematicians who wanted to teach a lot of content and education philosophers or researchers who wanted to do things in a way that was felt really good for the students. And I don't want to totally discourage either one. I think they both were a little bit wrong in their way, they recognize that this takes a long time to do it in a way that feels good and exploratory. And so they started to pull back on the need to actually teach mathematics. And the enrollment in algebra of high school students declined sharply from like the early 1900s to 1955. They weren't even taking algebra in high school. Like they could just get out of high school without any algebra. All right, so anyway, after Sputnik, we decided to maybe revisit that. And in the constructivist movements of exploring, though, one of the things that sometimes is missing is the direct connection to the abstract. I don't actually recommend a lot of play with manipulatives without always connecting it to some level of abstraction. And that abstraction in and of itself, just the way that these could, these are all physical, tangible models, but they themselves have a transition from concrete to abstract. So can your more abstract representation can also transition. Okay, in ELA, you know, we think about, there's this big push. We just released a new ELA curricula, and as I was talking to the writers of our curricula, they were like, oh yeah, you know, we really believe that building content knowledge is critical, that if you don't have some content knowledge, like either something nonfiction around science or something fictional or nonfiction around history or some actual knowledge of what's happening or what happened in their world, that writing meaningful, it doesn't happen. You can't write well and write meaning if you don't have something to write about, right? And I was talking to Jason Zemba actually about the same thing, about in math, there's all of this use real world applications, real world problems, but that actually starts to require some content knowledge before you get too far along. And so his pushback was just that we need the time to do the math and not to build too much content knowledge and to leave that to the other curricula to be doing that content knowledge building. But I'm interested in having sort of a coherence thread throughout the curricula of sort of three main strands of application, one being sort of economic and financial principles, one being physical sciences, and one being sort of social sciences and data and statistics and whatnot, so that we do sort of build some content knowledge, you know, throughout the years. All right, I'm told my time is up. Thanks so much.